Okay, this is IM2. This is 4-1. This is about mid-segments. So what I'm going to do in this video is I'm going to actually prove out how we came up with the hypothesis that the mid-segment is half of the parallel side. All right, so I'm making a triangle here and I'm calling it A, B, and C. All right, so I have laid this triangle on its side and we are going to go ahead and draw it out. This is a triangle that's actually found in your book, so I am literally just copying out the triangle. So B is located at when it's located at 6, 0. So X is 6, Y is 0. A is at the point of 4, 6. And of course, C is at the origin at 0, 0. So I'm going to do a mid-segment here. And the mid-segment is going to be located right here. And I put it there because this line, we can find where to put this point right here based on you need half of the x value, so half of that is 2, and you need half of the y value, so half of that is 3. So this is going to be at point 2, 3. I'll call this D. And then the same thing here, half of the x value is 3 and half of the y value is still 0. So we're going to put it right here. So this is my this is my mid-segment right there. All right, so what we're going to prove is we're going to prove that this is half of the length. I can prove in a different video if you want, or you can calculate it. Actually, we can do it pretty fast, that the slope is the same. So the slope of D is 1, 2, 3 over 1. So the slope is, the rise is 3 and the run is 1. So the slope is equal to 3 over 1 or 3. The slope here is 1, 2, 3 over 1. The slope for this one is also 3 over 1, which is 3. So if we have the same slope, we remember from earlier linear equations that if it's the same slope, then they must be parallel. So these two lines are parallel. This is the mid-segment for these two right here. All right, so we're going to use the distance formula to prove that it's half of the length. If you've forgotten, I'm going to put it on here. So the distance formula is equal to, D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, we know how to do all of that math. That's just filling it in. So let's find the distance of this line here. So the distance of AB. All right, it is equal to the square root of x2. We'll call this point 2 and this point 1. x2 is 4 minus 6 squared plus 6 minus 0 squared. 4 minus 6 is negative 2. Okay, so AB is equal to the square root of 4 minus 6 is negative 2. Negative 2 squared is 4 plus 6 minus 0 is 6. Squared is 36. All right, so AB is equal to the square root of 40. If we wanted to finish that out, the square root of 40, AB, is equal to the square root of 40, which is equal to the square root of 4 times 10, which is equal to, we can pull the 4 out, so that's 2 times the square root of 10. All right, to finish this off, we need to calculate the distance of D to E. All right, so the distance of DE is equal to the square root of, this is 2 and 3, so we'll make D our second point. So 2 minus 3, right? x2 minus x1, this point right here was 3, 0, squared, plus 3 minus 0 squared. All right, so DE is equal to 2 minus 3 is -1. -1 squared is 1. Plus 3 minus 0 squared is 9. So 3 minus squared. So DE is equal to the square root of 10. And what we're seeing here, we can actually leave it where it is, because AB, we just calculated, was 2 times the square root of 10. And DE is the square root of 10. So thus we've proven, I'm going to just write that, thus the midsegment is half of the length of the parallel side.